My name is James Davis, and I will be doing my material science project on polydimethyl siloxane, also known as PDMS. So PDMS is a significant material due to its diverse properties. Firstly, due to its biocompatibility, which ensures that it's non-toxic and it doesn't elicit any immune response when it comes into contact with biological tissues. And this is useful for things like medical implants or even drug delivery systems. It's also optically transparent, so this could be useful for things like microfluidics, where you want to observe fluid flow in microchannels. PDMS is also flexible and elastic, and this has uses for soft robotics and even flexible electronics. It's also chemically stable, has a high chemical stability, so this can prolong its uses in harsh environments. It just makes it a more robust material in general. PDMS also has low surface energy, which results in a sort of non-stick surface where it can repel polar and non-polar liquids, and this is useful for its uses in coatings and things. So just a little bit about the chemistry of PDMS and silicones in general. So polysiloxanes, also known as silicones, they feature a backbone of a silicone atom attached to an oxygen with two R groups. And these R groups can be different or they can be the same. It doesn't quite matter. But all polysiloxanes are inorganic polymers since they do not contain a carbon backbone. And so PDMS has two methyl groups as its R groups. And a little interesting fact about PDMS is that the monomer is an 8-membered ring. We can see it right here in figure 2 with the 4 oxygens in red and the 4 silicone atoms in yellow. And unlike most polymerization reactions, which are enthalpy driven, the polymerization of PDMS is actually entropy driven. So a little bit about the properties of PDMS. It has a low thermal conductivity, which makes it a excellent insulator. And it has a low Young's modulus, which kind of characterizes that high elasticity that it has. But if you'd like to strengthen the material and not have it be so elastic, fiber reinforcements are known to be a good alternative for that. It also has good biocompatibility, like I said earlier, which ensures that it's non-toxic and there's no immunological response there. It's also highly hydrophobic and oleophobic, so it repels both water and oils. And this is a interesting property since most compounds or molecules are usually one or the other, but PDMS is both. If you'd like to improve upon this property, beeswax has been known to be a useful additive. Additionally, PDMS is selectively permeable to gases and is impermeable to liquids. And this can be disadvantageous or advantageous depending upon your application. So like for instance, gas permeability would be disadvantageous if you were trying to analyze cell cultures. Finally, PDMS can become optically transparent under temperature gradients, and this process is actually reversible. And this can be useful for making an optical film for whatever application you might need. So, industry applications of PDMS. PDMS is used in coatings like Rain-X, and this is due to its highly hydrophobic behavior. And it's useful for like just general water-oil separations. PDMS is also used in soft lithography, which soft lithography, as we look over in figure 3, it's essentially the process of replicating structures using an elasteric mold. And one use of PDMS in soft lithography is for microfluidics, which is the creation of these micro channels, and then you observe the fluid flow in these microchannels. PDMS is also used for stereolithography, which is a form of resin 3D printing, as we see here in figure 4. This is kind of just how stereolithography is done, and this makes PDMS becomes useful for things like prototyping or creating molds here. And it's also, PDMS also has uses for lubricants and industrial lubricants and surfactants, since it has that low surface energy, which reduces the surface tensions of mixtures. It's also used as an anti-foaming agent, and so in the food industry, it's used as an anti-foaming agent to actually reduce oil splatter, which is quite interesting. So overall, PDMS is a really versatile material, and it has a lot of unique properties. And I think it's important that we encourage this exploration and innovation of polymers now and into the future. Here are my references, and thank you for listening.